To understand the structural integrity of this marvel, we isolate the primary actuator assembly. Inside the casing, as we cycle the actuators, note the fluid dynamics and the resulting pressure spikes within the system.
This magnificent structure is an engineering marvel. Analyzing the core system reveals the intricate mechanical.
The immense scale of this deep-water construction relies on the dynamic load balancer. As we explode the view, the deep-water foundation system utilizes advanced hydraulics. As we cycle through the stress test, the internal mechanics reveal the true power. We measure pressures up to 120 bar and speeds reaching 80. Analyzing the system in detail reveals the synchronized precision of the actuators. As we simulate the operation, as the main assembly separates, we see the hydraulic power unit feeding the impact hammer. Note the precise. As the assembly completes, the semi-transparent view reveals the core mechanics. Piston actuators drive the hammer. Essential for deep-water construction, the impact actuator generates immense force. Our simulation reveals the pile driver delivers consistent, high-impact energy. Through this detailed technical analysis, we observe the flow of wind. The large-diameter caisson installation barge is critical for deep-water construction. We can see the power source. The large-diameter caisson requires precise control. Here we analyze the complex positioning system. We begin with an exploded view, highlighting the dynamic positioning thrusters and the winch synchronization system. The caisson installation barge rely on this complex positioning system. An exploded view details the key components. By utilizing X-ray ghosting, we observe the internal mechanics. Note the critical fluid circulation as the
The lowering of the caisson is an engineering marvel. Analyzing the system reveals the intricate mechanics.
Dewatering the caisson allows for the precise pumping of high-strength concrete. Our analysis reveals the intricate mechanics.
Analyzing the mechanism's application. In this detailed 3D exploded view, we identify the power source and actuators. Analyzing the deep-water concrete foundation, we transition to a detailed 3D model, revealing the internal mechanics.
From the demanding environment of the deep-water site, we transition to the core mechanism. An exploded view reveals the actuators and power source. In X-ray mode, we observe the precise flow of hydraulic oil, visualized in yellow, maintaining pressure at a. Utilizing the self-climbing formwork system allows for rapid vertical construction. Let's look closer at the internal mechanics. Analyzing the system, we see the main assembly separate. The hydraulic climbing jacks are critical, operating precise.
The system's efficiency relies on the integrated hydraulic loop. Here, we see the actuators engaging. Pressure.
To understand the mechanism, we observe the internal fluid dynamics. The system operates under significant stress. The system provides unparalleled stability. Here, we analyze the core components, highlighting the power source. At this deep water site, the crane lifts massive loads. A closer look reveals the intricate workings of the hydraulic system. The slewing mechanism is the heart of the tower crane. Let's examine the critical components in this exploded view. To understand the operational dynamics, we first isolate the main drive and the ring gear. Reassembled, the slewing mechanism is critical for heavy machinery. We observe the exploded view, highlighting the power source and. To understand the mechanism, we separate the assembly, revealing the actuators. Reassembled in X-ray view, the exploded view reveals the core power system and actuators. Using X-ray ghosting, we observe the modular bridge tower system in action. To understand its efficiency, we move to a detailed 3D analysis. The modular system utilizes a sophisticated hydraulic network. As pressure reaches 120 bar, the culmination of engineering, the modular bridge system in action. Analyzing the assembly, we examine the power source. The main cables are the heart of the suspension system, visualizing the tension across thousands of individuals. The X-ray view reveals the precise mechanical movement within the actuators. As you can see, the aerial spinning wheel system is critical for the main cable weave. Let's examine the internal mechanisms. As
The aerial spinning wheel system utilizes high-pressure hydraulics. As the internal components engage, the system maintains
As we initiate the exploded view sequence, the sheave assemblies and cable tensioning rollers detach gracefully. Observe. The aerial spinning wheel system ensures smooth cable tensioning. Here, we analyze the core assembly. Note the pressure. Analyzing the sheave assembly. The exploded view highlight the power source and actuators. In X-ray mode, at the deep water construction site, the aerial spinning wheel system continuously tensions the main cables. The aerial spinning wheel system efficiently bundles thousands of wires. Through this exploded view, we identify. The exploded view reveals the actuators and power source. In X-ray mode, we see the hydraulics engaging at 100.
Analyzing the T8 compactor reveals the hydraulic power source and actuator assembly. Note the extreme pressure, peaking at...
To understand the operational need, we analyze the highly detailed 3D model. The exploded view reveals the power.
The exploded view highlights key components, demonstrating the precise engineering. As the machine reassembles,
As the hydraulic dies engage, the glowing yellow fluid indicates immense pressure, reaching 300 bar at the point of compaction.
analyzing the tensioner reveals the intricate mechanics.
As the gears rotate at 80 RPM, pressurized coolant. By isolating the main assembly, we reveal the critical power source and the hydraulic actuators driving the tension process. This highly detailed 3D model allows us to visualize the internal mechanics. The hydraulic power source drives the robot precisely secures the clamps. Analyzing the internal structure reveals the sophisticated hydraulics. Field application demonstrates the robot's power. Now, analyzing the assembly, we see the actuators and power source. The robot achieves precise clamping force. As we transition to the exploded view, the actuators are highlighted. From dramatic on-site application to the precision of the studio, this exploded view details the main power assembly and
Beginning with the real-world application, we transition to a detailed analysis. The exploded view highlights the power core.
These suspender cables are critical links. The internal hydraulics manage the immense pressure, visualized here.
The segment lifting gantry system precisely maneuvers massive loads. Here, we reveal the internal mechanics. Note, we analyze the segment lifting gantry system. The exploded view reveals key components before switching to X-ray mode. We begin with an exploded view, highlighting the trolley hoist units. Now, in X-ray mode, observe. The segment lifting gantry system reassembles, revealing the core actuators. In X-ray mode, we analyze. As the hoist engages the load, the cables tighten. Friction sparks are visible at the pulleys. Analyzing the crane's primary actuators reveals the immense pressure required. With the X-ray view, we track the hydraulic. To understand the operational need, we analyze the core system. The exploded view reveals the actuators, where pressures.
Hoisting the deck segment demands absolute precision. At this critical connection point, the bolt tension reaches exactly
Operating at depths of 100 meters, the foundation drill's efficiency is paramount. Through this exploded view, the segment lifter demonstrates remarkable precision. Internally, the hydraulics operate at peak efficiency.
As the machine layers the final surface, we transition to a detailed analysis. The exploded view highlights the pattern.
In this detailed analysis, we see the power core assembly. The system hydraulics reach 120 bar.
As the system operates, we visualize the precise mechanical movement of the pistons and gears. Note the fluids. The automated pavement layer reassembles with precision. Observe the powerful hydraulic drives and the glowing yellow fluid.
In X-ray mode, the internal workings reveal the pressurized fluid powering the drum. This generates a compaction force.
The specialized paving machinery ensures a rapid, smooth surface. Analyzing the 3D schematic reveals the robust.
We begin with the exploded view, highlighting the power source and hydraulic actuators. In X-ray mode, the
bridge inspection drone ensures structural integrity. Analyzing the core components, we see the primary power source. The drone's modular design allows for easy maintenance. As we move into the X-ray view, Observe the pressurized. Analyzing the internal structure reveals the precise mechanical movements. Pistons fire rapidly, driven by the turbine.
We begin with an exploded view to identify key components, then simulate the internal hydraulics in X-ray mode.